inequalities are those equalities where the power of x, the power of the variable is just 1. So where the power of variable is just 1 is called linear inequalities. So we'll study about the strategies that how to solve the linear inequalities uh, in this tutorial. So here the question number 1 is in front of us. If x is smaller than 5 on a number line. So if it's a number line here and it's 0 and -1, -2, -3 and 1, 2, 3, 4, 5, which says x is smaller than 5. Now we have to look for this symbol. It's just smaller. So when it's just a smaller, it's called exclusive. Exclusive. Exclusive 5. That means 5 is not included in this. So 5 is not included and the x is a number which is smaller than 5. So how we are going to represent is we'll put a dot, a circle that is hollow, and we'll just draw a line, point an arrow, and write x here. So now this hollow circle indicates that this is only smaller and the 5 is not included in this inequality. And on the other way, if there is x is smaller than or equal to 5, then that means this type of inequality is called inclusive. Inclusive inequality, and inclusive means that x is smaller than 5 and that includes 5 as well. So x is smaller than 5 or x is smaller than or 5. So 5 in itself is included. X is either 5 or smaller than 5. So in this case, we can draw this inequality is we have to put a solid circle here and then we have to draw it towards the side towards which it is smaller. Now this is x is smaller than or equal to 5. So x is either equal or smaller than 5. So this is how you have to draw these inequalities on a number line. So in question number 2, write down the inequality shown in the diagram. So here we can see that 8, it's on the 8 and here it's a hollow circle. So x is smaller than 8 because this circle is not solid. And here on the 2, we can see that this circle is solid. So that means x is greater than -2. So we write is -2 smaller than equal x and x is smaller than 8. So this is how we write. We see on the 8, so the x is between 8 and -2. And how is this relationship? It's like x is smaller than 8. So it's not equal to 8. X can be smaller to 8. That means 7.99 below it is. And x is greater than -2. Greater than or equal to -2. So we can write this as -2 is smaller than or equal to x and x is smaller to 8. So this is how we write this inequality. In the next question, it's a solve. When the question is about solve, then you have to find the value of unknown. Unknown, whether it can be an x or y or a or b, whatever it is. So you have to put everything to other side of the inequality, and then you can just simplify it. So the rules of algebra apply here. So whatever are the rules of algebra you already know, so those rules will apply here. So if something is multiplying on a right side of this inequality, when it go to the left side of this equality, it will divide. So you can write it as y is greater than 24 over 6, and then you can simplify and write y is greater than 4. 6 fours are 24, so y is greater than 4. This is a simplified version. And here it says solve. So in this inequality, we have to solve. So that means that we have to isolate this unknown variable x and put everything else to other side of this equation. And we have to just apply the rules of algebra here. So we solve it like first we write 2x is smaller than or equal to -8 and -4 and -8, because this is a positive 4, so when it moves to this side of the inequality it will be -8. So 2x is smaller than or equal to -8 and -4, it makes -12. Okay, and then again x is smaller than or equal to, this 2 is multiplying with the x, so when it goes to other side of the inequality it will just simply divide, right? So now our answer will be x is smaller than or equal to -x. In the next question, we'll solve this question. Here we have got two variables. One is -6 and other is -2. So in this type of inequalities, our attempt should be that we make this variable positive, unknown variable positive. We try to keep unknown variable positive. Otherwise, if it's negative, then you have to switch the inequality sign, and that becomes a little bit confusing. So keep the unknown variable positive. This should be the strategy. Now here it's a 6x and on left side it's 2x. So if we move this 6x here, so it will be -6x, and then with positive 2x our will the outcome will be -4x. So this variable, unknown variable, will be negative. So we will not apply this strategy, and we will move this 2x to this side of the inequality and this 8 to this side of the inequality. So this will look like -8 +7 is smaller than 6x minus 2x. So this will give us is -1 is smaller than 6x minus 2x will be 4x, and then x is greater than -1 over 4. So this should be our answer, because this 4 when goes to other side of this inequality it will divide, because on this side of the inequality it is multiplying with the x. So that should be our answer for this question. Okay, the question number 6 says like this: -3 is greater than -5b plus 7. So here in this type of inequalities, we can see that here this b is negative, right? So as I previously said that we need to have this variable, unknown variable, positive. So for that purpose, what we do is we move this unknown variable to this side and the constant numbers towards this side of inequality. And that will make our solving the problem pretty easier. So we move this to this side and it becomes positive 5p, and we do not change this inequality sign. It remains the way it is. Just this negative, when comes here, it becomes positive, and this 3 is negative, so when it goes to other side, it becomes positive 3 and plus 7. So now this gives us 5b is greater than 7 plus 3 is 10, and b is greater than 10 divided by 2, or b is greater than 5. So this is the answer for our solution. And for this kind of inequalities where we have got an unknown variable in the center and two equalities both on right and left. So if this kind of situation we face, we need to just make the center variable isolated. Whatever are there between these two inequalities, so we have to move them to both sides of the inequality and just eliminate them. In other words, how can we solve this is like we have to eliminate this 3. So to eliminate this 3, we divide this whole inequality with 3. Divide this with 3, divide this with 3, and divide this with 3. So we are left with 5 over 3 is smaller than or equal to x, and smaller than equal to 18 over 3, or in other words, if we convert it into decimals, and 5 divided by 3 gives us 3 ones are 3 point, and 2 and 0, 6 are 18, 3 6 are 18. So if we divide 5 divided by 3, it gives us 1.6 is smaller than or equal to x, and it is 3 6 are 18. So this should be our answer. So this is one way of solving this inequality, and the other way is that what you have to do, simply you change this inequality into two portions and then solve them separately, and at the end what you do is combine them again. So that will be like 5 is smaller than or equal to 3x, and then 3x is smaller than equal to 18. So you just simply move this here. 5 over 3 is smaller than or equal to x, and x is smaller than or equal to 18 over 3, or x is smaller than or equal to 6, and then you can just combine at the end. 5 over 3 is smaller than equal to x, and x is smaller than equal to 6, like this. So first solve them separately. This is helpful when you have a very complicated inequality to solve. So here in this type of equation inequality, we have again got two different inequalities. So we are going to solve this the same way. First, we subtract this whole inequality by negative 19, because we want to eliminate this negative 19 from the center, because we need to have this only x left here between these two inequalities. So anything else over here, we have to just eliminate them. So 19 minus 19 smaller than 4x plus 19 minus 19 smaller than 30 minus 19, because all these three are the different portions, right? So whatever operation you do, you have to do with all three components, sides of this inequalities. So 19 minus 19 is 0, smaller than 4x, and then these two cancel out, smaller than or equal to 30 minus 19 is 11. Now we have to eliminate this 4 because we just need this variable, unknown variable in the center. So just to eliminate this 4, we divide all sides by 4, right? So we are left with now 0, because anything divided by 0 is always 0, and x smaller than equal to 11 over 4. So if we further divide this one, our answer will be 0 is smaller than x, and x is smaller than or equal to 4 2's are 8. We put a point in 9 10 11, it's 3, and we put a 0, it becomes 30. 4 7's are 28, so 2.7. So this should be our final answer. Now in the next graph, it says shade the region represented by the inequalities. So we have to find in this graph, we have to plot a graph here and then find that which region this inequality is represented. Here it says x is greater than negative 3 and y is smaller than 4. So we have to find these two, we have to plot and find these two. If it is x is equal to negative 3, where would it be? So this is x-axis and negative 3. So I would try to plot this here. This is negative 3, and it says x is greater than negative 3. So the greater than negative 3 is this side, right? So the side which is not represented, I will try to just cancel it out to make it easier. So the x is greater, so the x is smaller, I'm just canceling this region, right? So this region x from here greater than 3, this region is the represented region, and when it's the same rule applies here as well. This is an inclusive, this is an inclusive inequality, so that means I have to draw a solid line here. So if it's exclusive, I have to put a dotted line. And the next is y is smaller than 4, and here we can see that this inequality is exclusive. It's exclusive. So when it's exclusive, I have to put a dotted line, and here it's smaller than 4. So 4 is here, and then it's a smaller, and I have to cancel it, the region which is not required or not represented. So the not represented region is bigger one, and the smaller one is represented region. So the bigger, the region which is bigger, I am going to cancel it out. Okay, so this is how we can do it, and this is the in fact region with, we can write r represented. So in other words, what you can do is you can just in this graph, the other alternate way can be that you can just shade the region which is required. I have shaded the region which is not required, and the region which is required I have written r. But in other words, you can, what you can do is you can shade this region which is required and just leave the blank one which is not required. That can also be a possible solution. Okay, so in the next question, it says shade the region represented by the inequalities. So I will solve whatever it says. Shade the region. So this time I will shade the region which is represented, right? And I will not shade the region which is not represented. I'll just follow these instructions. So here it says x is smaller than 1. Alright, so first our equation is x is equal to 1. So when x is equal to 1 and the inequalities is just smaller, that means that it's exclusive. So x is 1 here and this one is exclusive. So I have to put just dots here, right, with a dotted line, and the represented region is smaller than 1. So the represented region is smaller, that means the represented region is towards this side, right? The greater side is not represented. And then the next equation says y is smaller than or equal to here, y is smaller than or equal to 2. So first I write y is equal to negative 2. So y is equal to negative 2 and the line should be solid because it's an inclusive and negative 2 is here. So I just plot okay this one, and now the required or represented region is y is smaller than negative 2. So the smaller than negative 2 is downside. So this downside is represented region. So above side is not represented region. So now this side has already been cancelled out. This side has already been cancelled out by the red one. And now this inequality has cancelled out this region as well. Now you have to find the third inequality. It says y is smaller than or equal to x plus 2. So we have to plot this line y is equal to x plus 2. So when it's x plus 2, our equation is y is equal to mx plus c, and the c is y-intercept. The line is passing through y-intercept and it's a positive line, and the m is 1 over 1. Change in y and change in x is 1 over 1. So how to draw this kind of linear equation? If you do not know, you can have a look of my previous videos where I have discussed how to plot these kind of graphs. So in this kind of what we have to do is, this is a 2, y is equal to mx plus c, where this line is crossing y-axis, and for every 1 on the y-axis, rise over run is just 1. So the graph would be like this. Okay, and here it says that it's inclusive. Y is smaller than or equal to, so that means it's inclusive. So I have to draw a solid line all across. Okay, so and smaller than, so y is smaller below this line. So finally we are left with this region, uh, which is, because the region which is above this is also not required. So it says shade the region, so we can shade this region here. This is the final region which is a required region. So we can shade this and we can write this. This is required region finally, and all other regions, they are not required. Answer like this as well. So it's still better. So the option which I gave you before in the previous question, and the regions which are not represented, I have shared it here, and the region which is represented, I have left it as a blank, and I have written it as R. This is also one way, still it's correct. Or you can do the represented, you can just shade the represented region and write or and leave the other sides which are blank. So this is also one of the ways to solve the inequalities.